Okay then, so coming over to node B, so I'm at reaction. I've got my reaction R2, which is 3.5, coming on at B, and I have a vertical component there and a horizontal component there. So BK and BE are forces that I can determine. BK must be equal to 3.5 in compression. So basically this force comes in at this node and it must be resisted by a force acting downwards, so that BK is in compression. And similarly EB must equal 0 kilonewtons. Okay, so neither in tension nor compression. I then move to, we will go up to our node K. We know this is 3.5 in compression, and so this is JK and this is KE. So let's look at KE first, or EK, whichever way around. That is in the ratio of 5:4. If you remember our this is 3, this is 4, and this is 5, so our ratio is 5:4, 5/4, times 3.5, which gives us a value of 4.375 kilonewtons. Which is tension, we've said. So this force coming upwards has to be balanced by a force going in that direction, so EK is in tension at 4.375, so we can put that in there, 4.375 tension. And we can also determine JK. Let's just put these in, so that's JB, which is 3.5 kilonewtons in compression. And we can now work out JK, which is that's 35/8, isn't it? So I tend to work in fractions because I just find it easy, because I come from the days when we didn't use calculators so much. So that's in the ratio of 3:5, so that's 105/40, which is the same as 21/8, which is 2.625 kilonewtons, which will be in compression. So that's JK, 2.625. Okay, and from there we only need now to determine the force in JE. So we will do that from this 0.625. So we've got the JE. So this is our node J. Going down to E. We've got a force over here, which is JK, which we've just calculated as 2.65. But we can just do a quick check on that. So this is 2.25 compression. This one was the odd one, wasn't it? Because that was a 0.625 compression, so that flipped into compression. And this is okay. So JE, because that's compression, that's going up. So this here is going to be a tension. That's interesting as well. So that's compression load, so this must come down. So JE must be a tensile load, which kind of makes sense because we've got quite a big load hanging off it down here, this 4 down here. So that is equal to, the ratio again is 4:5 from these triangles down here. the ratio of the lengths of the sides is also the ratio of the forces, because the forces are vector forces. So JE is 4/5 of that 5/8. Which gives us, let's cancel those, 4/8, which is 1/2 basically. Kilonewtons, and that is kilonewtons in tension. Okay, and we can do a quick check for JK. JK is 9/4 plus 5/8 times the ratio 3/5, which is 9/4 plus 15/40, which gives us the one. So it's 90/40 plus 15/40, so that's 105/40, which gets us to that 21/8, which gets us back to the 2.65 kilonewtons in compression, which confirms this one as well. Okay, so now we've resolved all the forces in that truss. Okay.